I've never looked through those.
I want a pair of 45 by 70s. And
We're going live, by the way.
Okay.
Yeah. Don't stop talking.
Don't stop talking
Yeah.
about binoculars.
Yeah.
I don't know anything.
On the topic of recruiting people, we need somebody who is technologically capable to come assist on the Astro Imaging channel to be a backup streamer for me, because I'm the person who runs the stream, but I need a backup because our
I have
previous
no idea about that.
Isn't really involved in it anymore. So if you guys know anyone who is interested, who likes astrophotography-ish, and
this is the group to ask.
Yeah.
Okay.
Right?
You know, they don't have to have much streaming experience. Like, I'll teach them. Know their way around a computer would be a helpful place to start.
More of a visual observer. I dabble in astrophotography. I know enough to write about it, and I've done some astrophotography, but more of a visual observer. So.
Yeah, and on the Astro Imaging channel, we get guest speakers to come in. It's really just somebody to to operate the stream when I'm not available.
Hey everybody, welcome to the show. So sorry about last week. We had a whole bunch of separate scheduling problems, and then I had a bunch of emergency renovations that I had to do, so the timing worked out really well. So we're gonna I'm gonna talk to Avi Loeb and try and schedule another time to chat with him.
I was actually getting interested in listening to that one afterwards. After I heard the SETI talk that he did, that was kind of interesting.
Interesting, yes, yeah, yeah. I'm looking. I do want to just have a conversation with him. So I think it'll be we can clear some stuff up. Anyway,
that makes two of you.
Huh? Yeah.
I said that makes two of you.
Well, I mentioned this last week. Like I don't want to talk about Oumuamua being a alien spaceship. I want to talk about SETI's role and all that kind of stuff.
I like thinking about Oumuamua being a spaceship. Like,
cool.
I know it's highly unlikely, but it's still fun to imagine.
The reality is we're probably never going to know.
Yeah.
Because
we could know.
Oh, well.
We could know. Yeah.
We'll know about the next one.
Yeah.
Maybe as they flew through, they figured out that we broadcast on radio and they'll start broadcasting frequencies soon or something.
Sure, why not?
Yeah. Yeah. Well, the Europeans, they're going to have a chase. They're going to have a chase spacecraft ready to go to.
That's what we need is something in orbit ready to go.
Yeah, the interceptor. So
that's great.
They're going to be
so excited about that.
Yeah, they're going to be attaching it to Ariel, I think.
Oh, interesting.
Nice.
I didn't know that.
Yeah, so that's launching soon too. They're launching Ariel in 2024, 2028. So it's not going to be too long.
Soonish.
And it'll be an interceptor.
Maybe James Webb will be up by then.
James Webb is launching October 31st, 2021.
Is it? Is it
now that you've said it, it's going to be pushed back another 6 months.
What is the rule of this?
Is that how that works?
Fraser?
Every time you say that the James Webb is going to launch?
Every time you claim that it's going to launch soon, you add a month and you add $100,000. That's how it works.
$100,000? That's cheap.
$1 million.
Okay, fine.
Whatever.
$1 billion.
And Northrop uses the wrong material for the bolts again,
and loses a screw somewhere inside the telescope. That's how it's going to work. That's the rules.
James Webb will launch before SLS.
It'll be fine. It's going to launch. Everything's going to be great.
That I might believe, Dave.
Before we discover the wormhole out by Saturn.
There you go.
Right. All right.
I was talking with my old advisor, Jason, about really cool SETI thing involving Ariel. It was like using Ariel. So Ariel's like the exoplanet, like the atmosphere characterization telescope.
Yeah.
Like all the spectra of all the atmospheres.
Yes, please.
Yeah.
Yes.
It's going to be awesome. It was like,
it's
like the entirety of my thesis, like times a billion.
Yeah.
So.
Yeah.
Anyway, there was a recent grant that like NASA actually gave money to a SETI grant, which was like weird and new in its in and of itself, but it was using Ariel to detect artificial like chemical signatures in atmosphere.
Pollution.
Pollution, basically like CFCs.
Yeah.
Carbon pollution, things like that, but using Ariel to do it.
Yeah, we reported on that.
Super cool.
Yeah, so great.
Fine.
Oh, sorry.
You reported on it.
He put it in archive. He knew what was going to happen.
He did put it in archive.
Yeah.
I learned about it last year.
Well, why didn't you tell us?
That's the base.
Why'd you stick on it? Why'd you sit on the story?
Yeah.
Because I wanted to write about it.
Well, did you?
You got to jump on it. You can't wait around.
Yeah, you can't just save this stuff. All right, enough of this chit chat. Let's save this chit chat for
science with you people
for the show.
Disney.
All right,
Come here for this,
I'm gonna put you guys all back in your boxes. There we go. All right, back to me. And here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, February 24th, 2021. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about, directly imaging habitable planets. Yes, please. All things Perseverance and an extreme neutrino detected in Ice Cube. All right, not an ice cube, by Ice Cube. All right. Joining me this week on my screen, I've got Dr. Kimberly Cartier. Say the words.
Happy podcast day. Hello, everyone.
Hello, Kimberly. How's it all going there? How's your lockdown?
Still locked down?
Yeah, still.
It's the same as it was this time last year.
Same old. We're coming up on the 1 year anniversary.
Yeah, this is year 2.
Oh, boy.
We're in year 2 now.
Yeah.
Oh, goody.
It's actually, you guys are rolling out the vaccine pretty fast. I'm hearing a lot of really good news about how fast the vaccine is rolling out. It's kind of better news than here in Canada, actually.
Oh, really?
Yeah, they told us good news. Everyone in Canada who wants the vaccine will be able to get it by the end of summer. And I think you guys are already well into it. On my screen right now, I've got Molly Wickland. Hey, Molly. How's it going?
Greetings, Sky people. It's going okay.
And also lurking around, we got Dave Dickinson. Hey, David.
Hey, still here in Norfolk. Cloudy February, so it's really nothing else to do but write, pretty much. So.
And you've got a giant spacecraft just off to your right there. With
Which
the,
one?
The blue Yeti. That's the snowball.
The snowball.
Yeah.
So you're in the photo. Yeah.
Oh, is that a microphone?
No, blue snowball.
Yeah.
Actually, I got this when we started doing Google Space Hangouts way back when there was.
This is what my snowball looks like.
Yeah, it's a nice microphone.
What my blue eyeball looks like.
It just looks like a bomb.
Yeah.
Bringing
also,
if you're carrying it.
Yeah, bringing it through luggage.
I thought it was R2D2.
Oh yeah.
Yeah, me too. Actually, can I petition adding greetings, Sky people, to our list of greetings for this show? Because that was awesome.
Greetings, Sky people.
Greetings, Sky people.
You have to license that. I want to get paid for that one.
Happy Podcast Day is open source.
Okay, perfect. Yeah. Creative Commons 4.0. All right, before we get into the news, a couple of things. So we've got an interview, but it's pre-recorded. I know what happened in the interview, but you're going to have to find out. And so it's the interview is with Melissa Thorpe, a Canadian living in Cornwall, and is the managing director of the Cornwall Spaceport. So we talk about the weird reality that pretty much there's no easy place to launch rockets from Europe, and how they're solving this problem. And it's pretty clever, actually. And it's sort of a bunch of new interesting technologies coming together to make this possible. So I think you'll enjoy the interview. But that's going to be at the end. So we'll go till about the 45-minute mark, and then we'll switch over and I'll play the interview. So don't leave. Stick around. And of course, I want to give a huge thank you and a shout out to our good friends at the Weekly Space Hangout crew. They are our friends, our fans, our executive producers. They call all the shots. We just do what they say. And if you want to be a part of that amazing community, go to wshcrew.space and they will hook you up. And I am not kidding. They are in charge. We are just their humble servants. So join that community. If you ever want to write an email to an astronaut and ask if they can be interviewed, this is your chance. You can have all the credentials you need. You're an executive producer of the Weekly Space Hangout crew. All right, let's get on with the show. Molly, you're on my screen. Let's give people a nice little appetizer before we get into the main dish with Dave. So tell us about the most extreme neutrino.
Yeah, so I found the story particularly interesting because neutrinos are what I'm studying in my PhD. But if you're tuned into astrophysics news, you might recall several years ago that a super energetic neutrino went through the ice cube experiment down in Antarctica. Well, there's been another one, and this is the only the second one that they've been able to connect back to an astrophysical event that we witnessed. So this neutrino was detected in the Ice Cube Underground Neutrino Observatory in Antarctica back in October of 2019. And a paper that was published just recently connected that neutrino, that extremely energetic neutrino, to an event that was observed by the Zwicky Transient Facility on Mount Palomar of a black hole shredding a star in galaxy. It's got a great name. All right, ready for this? 2 mass X J20570298 plus 1412165.
So it rolls off the tongue.
yeah. Standard. Depends on the catalog. So let me see if I got this straight. Astronomers in Antarctica detected one neutrino.
Yes.
A very crazy neutrino, and they were able to trace the source of that neutrino to a black hole shredding a star.
In a galaxy 750 million light years away. Because in Ice Cube, because of the way that it's set up in their event detection with these multiple detectors under the ice, they can actually get direction information on where that neutrino is coming from. So based on its energy and based on the direction it came from, they're pretty sure that it came from this event in this distant galaxy that actually occurred 6 months before they saw the neutrino. So now we do know that neutrinos do not travel the speed of light. They have a mass, a very tiny mass, but they have mass, and so therefore they can't travel the speed of light. But because of the, I haven't done the math myself, but because of the distance that is traveled, the black hole shredding the star they think it might be kind of like an event that continues to produce neutrinos and other exotic particles after the actual event has happened. So that's some interesting new physics for the astrophysicists.
Well, and I know, we learned that neutrinos definitely aren't traveling faster than the speed of light, but a couple of years ago. But we do know that neutrinos, for example, can escape a star more quickly than the radiation can during, say, a supernova. And And so neutrinos can actually act like a warning sign that a star is about to explode as a supernova, which is pretty cool.
Yeah, and all the neutrino detectors around the world are always keeping their eyes open for a supernova neutrino signal, because if we can know some hours in advance that a supernova is about to occur, like we're about to see the optical signal from it, we can watch the rising of the optical signal, the supernova rising, instead of just catching it while it's falling, and that tells us a lot of important physics.
Yeah, there's like a worldwide network ready to catch the advanced sign of a nearby supernova, but it hasn't gone off yet.
Betelgeuse were to pop,
they would catch it.
We would get a warning.
Yeah, they would get about I think they get like about a 4-hour warning or something
from Betelgeuse.
Yeah. They would get a warning. I forget exactly how long it is, but they would get this warning because you get the blast of neutrinos, and then the light would show up.
Well, let me tell you about how energetic this.
Yeah, I was going to ask you, just how crazy is it? There's all these superlatives about how good this neutrino, how crazy this neutrino is. How crazy is it?
Yeah, so let me put it into some terms that will hopefully make a little more sense. So, in scientific terms, it had an energy of 100 tera electron volts. That probably doesn't mean anything to most of you. So for some context, it's 10 times the particle energy that can be produced in the Large Hadron Collider. And that still might not mean a whole lot to you. So let me put it this way. It's about the same energy as a mosquito flying at 8 miles an hour. Now, that does not sound like a whole lot of kinetic energy, but consider the neutrino is 10 quintillion, or 10,000 billion, however you like to think about it, times less massive than the mosquito. So think about all the mass energy of that mosquito flying around at 8 miles per hour, but now make the mass of that mosquito 10,000 billion times smaller, and think about how energetic that tiny, tiny particle must be. So
great
if
analogy.
that
Yeah, that's
particle
amazing.
came through your hand, you would never know. Because, I mean, trillions of neutrinos are flying through your body all the time. They just never interact with normal matter. They can fly through a light year of lead, and only half of a given group of neutrinos will interact with the lead, you know.
And so, I mean, we probably have neutrinos of this scale going through our bodies as well. We have a mosquito, an 8-kilometer mosquito passing through our body countless times because it just doesn't interact.
Yeah, and you know, because there's these really energetic events going on throughout the universe: black holes shredding stars, neutron star mergers, supernovae, black hole mergers. These all produce very energetic particles, not just neutrinos, but protons and gamma rays and all kinds of other stuff as well. But we got lucky in that not only did some neutrinos happen to be blasted our way from this black hole or this black hole star shredding event, but that it happened to pass through the ice cube detector, and that, you know, the one in hundreds of millions of neutrinos actually was detected by the detectors. So long odds, super cool event, very important for physics and very exciting for the rest of us.
Very cool. All right. Thank you so much, Molly. Okay, Dave, let's get into the big story this week. Perseverance landed on Mars
last Thursday.
What a show.
The collective internet held its breath last Thursday afternoon. Actually, this one didn't happen at 2 a.m. like Curiosity. So we didn't have to stay up, at least for us East Coasters. It happened right during prime time. I had to turn my Twitter off because it was running like a slot machine, but it's this was the third mission for this Mars season. We had the United Arab Emirates had the Hope orbiter entered orbit around Mars, and China's Tianwen-1, their very ambitious orbiter, lander, and rover combo is in orbit now, and that should be going down about in May. So it's going to be interesting. Of course, information just kind of trickles out. From China. As far as Perseverance was, this is NASA's 10th landing on Mars, and they've only failed one time, so that's pretty good. 9 tries for 10. The Mars Polar Lander is the only one they've ever lost back in 2003, I believe it was. But Sky Crane landing, we didn't see the video until Monday. We knew the still came out. They teased us with the landing Friday. We saw the still image of Perseverance underneath the Sky Crane, and we knew there was a video out there. People were getting a little irate this past weekend that the raw images were kind of being held back until Monday. Now there's a fire hose of raw images out there. You literally I've been trying to go through and look for anything interesting in there.
A lot of our good friends, Jason Major and others, have been digging through these new pictures, and I saw someone had found what looks like the plume of debris and smoke from the Sky Crane wherever it had crashed had been caught.
And there's some concern that this site is, they knew that they're going to this site specifically because Jezreel Crater there used to be, they know there was flowing water there. There's a delta there. This site is there to specifically address, was there ever life on Mars, and a cache sample for a sample return mission in a couple of years that on a date that hasn't really been released yet. But they know there's been some concern that there obviously is a lot of sand and debris at this site, that this might be more of it might have landed in a big sand trap. We won't know until they really get down. In the next week or so, they may start doing the first little motions with the rover, moving the robotic arm. Within a month or so, they want to put the Ingenuity helicopter down for its test flight. I know you guys have discussed that every time you fly the first time you fly a quadcopter, you crash it. So, but it'll take its first test flight. It will do a Perseverance selfie, and we'll all write our articles saying, "Oh, it's the first time a helicopter ever flew on Mars," and maybe it will crash. But that's okay. It'll be a first.
We got the first
time
microphone.
a helicopter ever flew on another planet any planet.
Yeah, it'll be the first helicopter flown and crashed.
I'm sorry, Dragonfly. Ingenuity is stealing your thunder. But
the Titan, yes, for Dragonfly. Yeah. But it's they're charging the Ingenuity. Obviously, the rover is nuclear powered, it's plutonium powered, like Curiosity was. The helicopter is solar powered, but it's charging off Perseverance right now. They're just doing a series of charge tests to make sure that it can take like up to a half charge or so. And then they're going to plop it down, and we're going to expect to see it flying shortly. You know what I think is interesting? Whenever they do, this occurred to me when we saw the landing video, that whenever they do a sample return mission in the coming decade, they're going to have to land fairly close, and it's going to have the return vehicle on it. So this is going to be a slightly different mission because it's going to have to launch from the surface of Mars. But if they land within a kilometer or two, Perseverance, I mean, Curiosity, here it is a decade and it's still running. Perseverance will probably still be operating. We may have that view from Perseverance as the other one comes down within a kilometer or two. That's going to be kind of interesting to see.
Yeah, well, I mean, the plan is probably going to be a little farther than that. I mean, Perseverance, because it's got a ton of artificial intelligence built into it this time around, a lot more even than Curiosity did. It's going to do a lot of its own wayfinding and navigation through some of the terrain that's in front of it. And so they're going to be doing things like make your way to that rock over there, and it's just going to find its way, sort of in the same way that it found its landing site. Like it used a ton of artificial intelligence to find a proper, to line up the perfect landing site and make sure that it was safe to land on. Amazing.
It was 11 light minutes away. So it had to do it on its own. I was amazed really watching the video that it wasn't as violent a landing as I thought, that there was no bounce back or everything. It's like, it wasn't spinning underneath. It's like, this is the first time we got to see how this landing works, like how it actually worked in reality. And it was pretty incredible to watch. I watched the video several times, and it was quite amazing.
Yeah, it never gets old.
So I mean, I have to say, I've never, like you said, Dave, I've never really had a good picture in my head of what a sky crane maneuver actually is supposed to look like. I mean, you say sky crane and you don't really know what that means. The crane in the sky, I suppose, but like to have like the hover, to see both the views from like the crane looking down at the rover and the rover looking up at the crane at the same time, you really get that very nice perspective of, here is this literally hovering, this crane hovering in the air, slowly, gently lowering this minivan sized rover. And it's like you said, it's over a ton. And it was just so smooth, so perfect. Like you said, there was no like abrupt motions. There's no like bending of the wheels or like any wobbling.
When we all saw this system back in 2010, I think everybody had the same reaction. We're like, that's actually going to work. Because from an engineering perspective, you're like, there's so many different things that could fail in the whole system. But so they've done it twice. So it's quite amazing.
I also really like NASA really tied it into that idea of sample return. Like they just kept talking about sample return, and as you said, right, the next step now is the Europeans and NASA are going to be collaborating on that next mission that's going to go to Mars. I guess after their Europe has their rover still to go.
Rosalind Franklin goes the next Mars window.
And then it's going to be collecting samples in the same way that Perseverance is going to be. And then after that comes the sample return mission, which is going to be a collaboration between NASA and ESA. And that, I mean, just to think that in 10 years, we will have a sample set returned back, a collection of samples of different interesting features on Mars in the hands of planetary scientists here on Earth for them to study in their lab. It's just,
China does want to do something like they did a quick sample return to the moon just this past December. And that was an all-in-one package, and they did it very, very swiftly, actually. So it's China is going to land. This next one isn't a sample return, but they're doing an all-in-one. That's never really been attempted where you had a lander, orbiter, and rover. I mean, Viking had a lander and an orbiter, or we had Spirit, Opportunity, Curiosity, Perseverance. Pathfinder didn't have an orbiter; it had a lander.
Oh, okay, you're right.
But it's to have everything in one package. I don't think has ever been done for Mars. But
yeah.
So I remember Pathfinder and Sojourner. Actually, that was the internet was just a baby back then. We all crashed our dial-ups trying to download photos of Sojourner.
Yeah,
remember that? So.
Yeah, it was amazing. I remember watching all that live. So we also got the first microphone.
Yes.
On Mars.
There was actually a hoax going around a few days prior where there was anybody that followed these missions, we knew it was a hoax because the video they put out was from Curiosity, but it's claiming to be the microphone sound. But on the press conference Monday, they did release the actual sound from Perseverance has 2 microphones on board. So that was kind of a nifty first too.
Yeah, unfortunately, it failed on the actual descent, and so they got a little bit of it when it was on the surface, and they got some of the wind noise and some of the, just it sounded like the rover. Most of the noise is just the rover itself whirring. Yeah, it was kind of disappointing, I gotta say. It was the thing that I was most excited to hear, but I hope over time they'll spend some time with the rover sitting.
Were you expecting a symphony on Mars?
I was expecting.
What were you expecting?
I want to hear.
There's nothing there except robots
blowing
and
wind, crunching sand,
it's
the
not
scampering
yet.
of Martian.
I think it was
Wait
Nancy.
until it starts moving. We'll get the crunching of the wheels over the rocks. We'll get the whirring of the helicopter.
The crashing of the helicopter.
Just landed.
I know,
okay.
I know, but so I've just for the first audio that they released, but imagine if it had worked while it was descending, going through buffeting by the wind, all those sounds. That would have been great. So
I think Nancy mentioned on her Universe Today article on the microphone that it had a long, they had tried to get one on Insight and it had failed. There's a long history of trying to actually get a microphone to Mars that functions. So there had been missions that had been, I think it was Mars Polar Lander we talked about, had one on board, it crashed, Insight's microphone failed. And then, so this is the first time they had one that got to Mars and it successfully operated. So
there's been multiple microphones removed from missions as well because they just couldn't spare the either the energy or the weight budget. So not only did we get the actual all the stuff that Perseverance captured, but once again, Lunar Reconnaissance Orbiter took pictures of it landing as well, which is just stunning to see a picture of a spacecraft landing on a planet.
It had caught Curiosity before too, but Mars Reconnaissance Orbiter is an amazing asset we have. But it's essentially a spy satellite class camera in orbit around Mars. So so what's the plan now? How do you know how things are going to play out over the next couple of weeks? I mean, the images are starting to show up. What happens next? They're going to do a short drive. I know from what I've seen reading that they're going to do a short drive to test it out. They're going to flex the arm. They're going through all the systems on it. They're going to actually deploy the helicopter. They said within a month or so. So that's going to be something that we're going to look for. So they're going to actually get out, move around a little bit, just put it through its paces and kind of explore Jezero Crater a little bit. And
again, as you said, all the pictures are being deluged onto the internet. So if you want to practice seeing alien fossils and stuff, you can look through the live images just like anybody else. NASA's not hiding anything, and if anything, it's too much. It's too much information.
I'm always looking to see if they get any interesting astronomy. Like sometimes they've caught the Phobos and Deimos when they're looking at the sky before, or things from the other rovers. So it's always interesting to see if they catch anything skywise.
Yeah, we've seen pictures of Earth seen from the surface of Mars, which is kind of cool. Awesome. Well, I'm sure this is not going to be the last time we're going to be talking about the discoveries made by Perseverance. This is going to be it's just like they've doubled their science capability now, and it couldn't be in a better place. Advanced technology, mobility. And all the rovers they've landed have gone way past their warranty date. I mean, Spirit and Opportunity they were only for 90 days and they went over a decade, and Curiosity is still going. It landed in 2012. So this one is supposed to go for 1 Mars year, which is about 2 Earth years, but with a plutonium power source, it could go for a while. Yeah, we're still hearing from the Voyagers.
I'm really hoping it keeps going until that sample return mission, like I said, lands nearby. So that'll be interesting to see.
Yeah, fantastic. So excited. All right, Kimberly, what do you got for us?
Hello. Well, now I have to shift my brain from the awesomeness of Perseverance, which I will say I've still not learned how to spell Perseverance. But maybe
I learned a trick.
Over the 10 years of its life.
Here it is. Here's the trick I learned. Sever,
yes.
right? Like to cut. Ants.
A-N-T-S.
Sever. Yeah, if you want. Or
It doesn't look right when you spell it.
But it's the sever. Sever. You'll never forget it now.
Okay. I will forget it in 10 minutes. Sorry. It's just how I roll.
No, I understand.
Anyway, I'm going to shift gears to planets outside of our solar system and how we can detect them. I think when we think of how to detect exoplanets, the two techniques that immediately come to mind are radial velocity, because it's been around forever, and transits, because we just have thousands and thousands of transiting planets thanks to Kepler and TESS and future missions that will happen. Sort of the unsung heroes of exoplanet detection, but that arguably give some of the coolest results, I think, are astrometry and microlensing and direct imaging. Astrometry is cool. We just don't have all that much of it. Sorry, astrometry people.
Gaia's going to deliver.
We'll get there. Yeah. We'll get there, but not just yet. Anyway, microlensing and direct imaging are two of the other big ones, but we don't hear all that much about them because they're rather limited at the moment. Direct imaging in particular is really interesting because it can detect planetary systems that are in orientations that basically no other technique can find. Transits, radial velocities, astrometry, all of that can find planetary systems that are sort of edge on. So we're seeing like the really thin part of a disk like this. Direct imaging can see things that are face on, where you see like the face. And so you get a more complete picture of what exoplanets look like. But direct imaging so far has only really been able to detect very young planets that are still very hot, because they've only just formed. And those planets are, generally speaking, pretty far away from their stars, because in order to see the light from the planet itself, you have to block out the light from the star. And that's just a limit of our current technology. But what's really cool, there was a paper that just came out that talked about a new technique using the Very Large Telescope, which is a very large telescope, to detect directly the habitable zone around Alpha Centauri A and B, which are two of the closest stars to our solar system. And now Proxima Centauri, we know, has a planet, maybe two. Alpha Centauri A and B, we haven't really figured out. So far, no. But if Proxima has rocky planets, maybe Alpha Centauri A and B do also. So, by using the Very Large Telescope for 100 hours of observing time and combining all of the images in the mid-infrared, the astronomers were able to use some very advanced adaptive optic techniques, basically noise-canceling headphones for a telescope, to get an order of magnitude more sensitivity to detect down to a super Earth sub-Neptune size sensitivity around Alpha Centauri A and B, which are kind of brightish stars compared to Proxima Centauri, the third star in the system. So that in itself is pretty impressive. Getting a whole order of magnitude more sensitive with direct imaging gets you to the habitable zone of Alpha Centauri A, which they were able to observe. And they found a teeny tiny little blip in that habitable zone, which they're very cautious, and they're saying that we don't know that that is a planet in the habitable zone of this star. But it sort of looks like what a planet would look like. And so in a couple years, they're going to go back with this same technique and look at Alpha Centauri A again and see if they see the same blip, but shifted just a little bit around in its orbit.
Yeah. Another 100 hours.
Another 100 hours on VLT. So they've not detected a habitable zone planet around Alpha Centauri A. That's not what they're saying. But they've demonstrated that the technique can work with our current technology to detect potential rocky planets in the habitable zones of stars, which is something we've never been able to do before. It's something that we hope to do one day with things like the ELT and the GMT. But those are decade and a half away.
Well, the ELT will be here in 5 years.
Will it?
Yeah. Yes. Just like James Webb. Come on.
Twice. That's twice in this call, Fraser. Come on. It's December now. It's December now.
You're doing this all.
I can't help myself.
You're doing it.
It's all my
Anyway.
fault. But yeah, no, the ELT in theory is 2026.
I think LSST is next year, isn't it?
Yeah, this year.
LSST, sure, but
Europa,
LSST was not designed to do direct imaging of exoplanets.
Time is moving.
Time is
Telescopes
moving,
are building.
apparently.
Actually,
Anyway,
the ELT
but-
they threw more budget at the ELT in the good way, like to advance
That's
its capabilities sooner.
That is good, but nevertheless, it is not yet here.
You're such
And I want to directly see these habitable zone
Yeah,
rocky
you're such a
planets,
cynic.
please. I am okay.
Yeah.
When it comes to telescopes launching and getting first light, yes, I'm a cynic.
Yeah.
I think
Yeah.
I would call it a realist and not a cynic.
That's
Thank
okay,
you.
fine. But then you get to be pleasantly surprised if they show up on
Sure.
time.
Sure.
Yeah.
You know, I remember an era back in the 1980s. This is going to date me, of course, but that there was an argument made by professional astronomers that we would probably never discover exoplanets because they were just too difficult at that time.
Yeah.
Yeah. Well, so what I find really compelling about this is that it's a demonstration that we can do this kind of science with our current technology. If you can dedicate 100 hours of VLT time, which they have proven that it works, they will be able to do it again. And I will note that this is also science that the Roman Space Telescope will not be able to do. The Roman Space Telescope does have a coronagraph component to it to do direct imaging of planets, but it's in the visible light and not in the infrared light, which is what you really need to actually see rocky habitable zone planets.
The VLT does some amazing asteroid images too. I've seen like comparisons with Dawn at Vista in the ELT images, and it's pretty darn good, compared to even what Dawn's doing.
I mean, I think like everybody, and not gonna lie, we jumped on the Alpha Centauri planets angle, but I think you're right, Kimberly, that the real story here is the really clever work that they did to boost the capability of existing telescopes by an order of magnitude to do more observations. That's going to pay across this entire field and really build the sort of the capability of when that next generation of telescopes does come online. They will have 50 years of practice.
Thank you. They will have lots of years of practice.
Working with the VLT.
Lots of unnumbered years of practice. Just to be diplomatic here. Of practice doing this exact technique to find these types of planets.
Yeah.
They'll have the software ready to go. They'll have the people who are trained in order to do this as well.
And
so
it
all
could
of
even
that is
drive...
Whether or not there's a planet in the habitable zone of Alpha Centauri, who knows? Maybe one day we'll find out, but the more important thing, I think, is the advancement of the field and the development of this particular technique, which
I do like that
way beyond this one planetary system.
I do like that sort of that process. Like even when we think about exoplanets, just in general, that like there was when astronomers first used Hubble in a way that it wasn't really intended to find a planet, and then it was able to help find more. But then they followed up with techniques and telescopes that were purpose built for this job. And I think, same thing. If you could compact down all of the learning into a very purpose built instrument, I'm sure you could start to see, more advances, more new discoveries. So yeah, direct imaging feels like it has to be the future. Like that is what we all expect when we think about finding other planets, not watching a star wobble, not watching a star dim.
It's the only direct method that we have. Everything else is indirect. You're looking at evidence of the star doing something that is probably caused by a planet, but you're not actually seeing the planet itself, except with this one method.
Yeah.
Except with this one.
Yeah.
Which is why it's awesome.
And you can see them face on, and you can see them at different angles. Yeah,
and you get totally new kinds of planets, and you can make movies of them. If you watch a star and a planet for long enough, you can make a movie of little planets going, which we have done, and it's still my favorite movie of all time. Sorry, Percy.
Huh. Yeah, don't make me choose. All right. Well, so we're going to shift over to the interview now, but you're on my screen, Kimberly. So tell us what you're working on, where people can find out more.
Well, people can find out more always on eos.org and on Twitter at AstroKimCartier. And as I was saying before the show, I just finished up a podcast episode, actually, with AGU, where I talked with my old thesis advisor, Jason Wright, about some really cool advances with SETI.
So where do people go for that? Just do a search for the AGU podcast or EOS?
Go to eos.org, and it's there under news.
Okay. Molly, what are you working on? Where can people find out more?
So my main website is www.astronomolly.com. Like in my little, I picked the right side this time, yay, my little icon up here. And that has links to my social media where I post most often, particularly Facebook. And I'm currently getting through a bit of a backlog of some astrophotos that I've been working on over the last couple of months in the last imaging season. So you should be seeing some new astrophotos coming up soon.
Fantastic. Dave.
Frequent contributor, Universe Today, Sky and Telescope, and I'm currently working on, we were talking about your newsletter process of getting stories out, that I found a story on there about researchers apparently think that Phobos and Deimos might have been the source of one object out there. That kind of caught my attention. I was just talking to the researcher, as a matter of fact, before we did the Weekly Space Hangout at the U.S. Naval Observatory. So it was kind of interesting. I'm writing that up for Friday on the possible source object for the two moons of Mars.
Very cool. Okay, and I don't have anything interesting to talk about. No. Universe Today on all the things. All right. Well, I'm going to put my co-host back on the screen. I know. I was a guest on the Sci-Man Dan podcast. So if you want to hear me talk about sort of my battle with conspiracy theory and that kind of thing, flat earthers, if you want to sort of hear a completely different side of the science outreach that I've done in the past, you might enjoy that, because that's of course his bread and butter. And so we talked quite a bit about where science misinformation is being spread and encouraged. And it's possible that we're using their service right now. Okay, so let me put my co-hosts back on the screen. There they all are. So thank you guys for joining me. I'm going to bid you all adieu now while I continue on my own to finish off the show with this week's guest. But thank you for joining us. We really appreciate it. And we'll see some random collection of you in the future. Everybody else, stick around. We got a good interview. Thanks, everyone.
Have fun.
All right, let's see if this is going to work. It does work. Look at me. That's a good pause shot right there. All right.
I'll have to listen to the interview now.
Sure, you can stick around if you want. I hope it'll work. I don't actually. It won't work for you because you're in the Zoom Hangout, so you're going to have to watch the show from outside.
You know something I saw that was nuts the other day? You can actually see the Crab Nebula Pulsar if you have a large telescope, like something like the Lick Observatory type telescope. That somebody did an actual video of it.
Hold on, I got to shift back to you now while you're talking. Okay.
Sorry.
All right. I got to start with the interview, Dave.
Go for it. Okay.
All right.
Have a good evening.
What? Okay, here we go. Melissa, welcome to the Weekly Space Hangout.
Yeah, thanks so much for having me.
Question I always ask people, who are you? What do you do?
So it's a good question. We were just having a chat a bit earlier about, I'm a Canadian, grew up on the west coast of Canada, Vancouver Island. And my father actually fought forest fires using, airplanes, and I grew up just loving. Yeah,
parked in,
absolutely.
Sprout Lake.
Yep, exactly. Yeah. So absolutely loved, going to bases with him and seeing, aircraft doing good positive things for the environment, for the forests of Canada. And I was massively into airplanes and wanted to be a pilot myself, but unfortunately I have not very good eyesight. So ended up randomly in studying economics, and I moved over to the United Kingdom to go to London School of Economics, which was my ultimate dream school. But I still stayed in the aviation aerospace world. I really focused on aviation and aerospace industries and how they work, and how they can develop whole regions around certain areas of where they do their technology and R&D. And after that, I was brought down to a rural part of the UK called Cornwall to help develop their airport. They have a really amazing asset down here. And the council had just bought it out from the military, and they were just looking at different kind of business ways to get some income into the area. And long story short, I ended up being involved with the spaceport when the UK Space Agency decided to create a launch capability in the UK, and we were shortlisted as a site. And that was about 7 years ago now. So it's been a roller coaster since then. And yeah, here I am. Day one, I was been involved with the project. But we're a very tiny team and growing now as we move closer to launch. But I've just now taken on the head role a few weeks ago. So leading the team towards launch in 2022. So not far away.
So tell me about the facility. Now you say this is an old military runway?
Yeah, well, it's actually a operational civilian airport. Before the pandemic, it was the fastest growing regional airport in the UK. So we have, daily flights up to London and Manchester and even down to Portugal and over to Spain. So it's an active airport. We have military operations that still take place, but we also have search and rescues based there. Our air ambulance for the area is based there. We have maintenance, repair, and overhaul. So it's quite a diverse aviation environment, and what we're looking to do is integrate space launch into that. So it's kind of a different way of launching. It's what we think is probably going to be what the future of space launch looks like.
And so what are the plans then to integrate space into a commercial airport?
Not very much, to be honest, and I think that's what's quite exciting about it. So our launch operator is Virgin Orbit, and that's basically a 747 that's been modified to carry a 70-foot two-stage rocket under one of its wings. So we're basically treating it as a 747. We've handled them in the past at the airport. So we're looking at integrating that into the air traffic management systems at the airport. And then once it takes off from Newquay, it goes up to about 35,000 feet and deploys the rocket from there. So that's when obviously the airspace changes, the range changes. But to integrate into the actual physical part of the airport, it doesn't really take much other than handling a 747 and finding her somewhere to live when she's here, because she'll only be here a few times a year to launch.
Right.
So we can pretty much do it tomorrow, which is exciting.
Yeah, and I know we actually just saw a first successful deployment of that aircraft launching a rocket into orbit. Why? I mean, when we think about spaceports, they're always somewhere near the equator because you want to take advantage of the Earth's rotation to either decrease the payload or be able to launch, farther. What is the advantage of a northern spaceport?
Yeah, so the beauty actually of what we're doing is quite different from, say, the potential vertical launch sites in Scotland, is with the Virgin system. She can actually go north and do polar, or she can go south and do equatorial as well. So depending on the payload requirements and the orbit inclinations and the trajectories and everything that the customer actually wants, we can almost accommodate for and can be quite flexible with the Virgin Orbit system.
Oh, that's interesting. Okay, so in other words, you could go more north and launch into a polar orbit, which is perfect. That's where England would be perfect for. But you could also fly south and still launch and have it go into an equatorial orbit. So you can sort of split. Exactly. That's really interesting. I never thought of that. Yeah. I mean, that's a real advantage of this airplane-based launch system.
Yeah, and that's the beauty of air launch itself, is you're kind of taking the rocket closer to where it potentially can be, but you're offering that kind of flexibility. And I think that's going to be quite huge as we have a launch capability grow in the UK. That it's just not, about offering the service to the UK only. It's about the wider, European market, and anybody close by that might want to take advantage of that. So yeah, it is different from other launches around. But and pluses and minuses to everything, but we think that flexibility is a huge tick.
What now? You say that you're probably going to see a couple of launches just a year right now. What do you think it would be sort of the capacity?
So Virgin Orbit Launcher One rocket, it carries about between 300 and 500 kilograms of payload. So obviously a load of small sats or nanosats to up to about a fridge freezer size. So that's, I think what we're all about here is growing as the market grows. This isn't, we don't want to go all out right at the beginning because the market might not be there yet. We have a big market in the UK and Europe, but we need to see, how that is growing, especially after the pandemic. But obviously our hunger as humans for satellite technology and space technology is only increasing. So it looks like probably the first couple of years we'll be looking at, 3, 4, 5 launches a year, but maxing out with Virgin at about 8 launches. And then we will be looking and working with other launch operators as well.
It's interesting. I mean, I know the UK has a very dynamic space industry. There's a lot of, really good satellite companies, satellite providers, manufacturers, but at the same time, not a lot of great ways to get that hardware onto launchers. You've got to, I guess in the olden days before the Brexit, you could join the Europeans down in South America or ship across the ocean to go to the United States. So there must be just like huge advantages for local builders to be able to deploy their satellites from UK soil.
Yeah, and that's exactly why this whole program started by the UK government. They saw a market opportunity to capture that in the UK, and they have an ambition to get 10% of the global marketplace in space by 2030, and this is one element of it. So they created this Launch UK program to be able to, almost cater for those homegrown satellite manufacturers that are, like you said, currently shipping overseas, getting bumped off of launches, not necessarily knowing when they'll be launched, having to store their products, shipping them. It is hard for those companies. So it's exactly why we're doing what we're doing. So we want to capture that here in the UK.
Now, you've got Virgin Orbit, but that's sort of part of another field as well, which is Virgin Galactic. Do you see any potential for being able to provide some kind of tourist flights in the same manner down the road?
Yeah, obviously the Virgin Galactic tends to get, the big headlines. I think what I always say is satellite launch is pretty tough in itself. So as we need to focus on nailing that first and getting that consistency and success up of that first. So that's all we're focused on right now, is just really securing that first launch with Virgin Orbit. Not to say, in the future, who knows? The way things are going, and it's so quickly as well in the space industry, to say that we wouldn't, it would be a bit crazy, because I think, as human space flight goes up and up in North America and you start to see it happen more, then I'm sure attentions will shift to other places in the world.
Well, I just think about
Cornwall's
capacity.
Well placed.
Yeah, I just think about the capacity. Like I know, like Virgin Galactic was going to be operating, or will still be operating, out of New Mexico with the Spaceport America, and they invested quite a lot to make a very specific experience that's going to go along with Virgin Galactic.
Yep.
I'm imagining you need a longer runway, like more facilities to be able to handle some of this. And I guess that's why I was sort of thought it's a little more interesting. Here on the West Coast, as you recall, we have Comox Air Force Base and a commercial airport, and the commercial airport only uses a fraction of the full length of the runway, because it's a military runway designed to handle. You can bring in giant Hercules aircraft and all kinds of things, right? So is Cornwall kind of the same thing, that it's sort of like an overbuilt runway for what it does from a commercial side?
Yeah, it's funny you said that, because when I first toured around it 11 years ago, I said to one of the guys at work, this reminds me so much of where I grew up, and the airport and the airbase in Comox, because it's exactly that. We have this in amazing facilities up there, this asset, this runway that, ours is, I think it's about just under 3,000 meters licensed, and then a little bit over unlicensed on either end. So, we have the space we can do it. Virgin Galactic, we have done initial kind of looks at it way back when we started on this journey, that there is potential. I think, again, it's about not only securing that first launch with Virgin Orbit, but all the other potential. Like, we're just scratching the surface of what the potential is for creating that launch, but we need to get that first.
Yeah.
And the window of opportunity, I would say, in Europe at the minute is closing, and there's other sites starting to pop up. So we just need to nail the market, and then we'll look what's next after that.
Well, and I guess that was sort of even just beyond the UK. I mean, I can't think. I mean, there's like some launch providers in Sweden. What else is close?
There's a site in Portugal in the Azores.
That's right. That's right.
Italy's looking at a few launch locations as well. And that was the thing. Like, if we didn't get this market secured, what a shame it would be to sit out on the beach in Cornwall and see launches going over from other parts of Europe. And we're like, no, we want that. We want it to come from Cornwall, because they would have to come over us to get anywhere. So yeah, there's definitely still potential that those will come. Like you mentioned, Sweden is definitely already operating. There's sites in Norway as well. So there's people hot on our heels.
And it is interesting. I mean, we've got sort of the same thing that's happening here in Canada with Nova Scotia. We've got a similar launch site being set up in Nova Scotia to handle polar orbits. I don't think it's going to be able to do flight-based ones. But I wonder, is there sort of a larger change that you're seeing? Because, I mean, we're all familiar with Cape Canaveral and the European Space Agency, and then there's some places in China and some places in Russia. Yeah. And that was sort of it for the longest time. But now I can't remember. I can't keep track of all of the launch sites. What do you think is driving sort of the newer sort of vast collection of launch facilities now?
So it's completely being driven by this, the commercialization of space. As you're seeing, back in the day, it was just sovereign launch. There was government. It was all government-led, state-led programs with space agencies heavily involved. And now you're just seeing these entrepreneurs entering the market. You're seeing private individuals, private businesses that are looking to get a piece of, the space pie for many different reasons. And all of them are demanding better access to space. So a handful of countries around the world pretty much launch. They're quite remote. They're quite rural. They're quite hard to get, their products to. And so what you're seeing is not only decreasing the cost of access in space, but being able to access the spaceports in general and almost, being able to show off what they're doing and have the public come and watch in these new places. And that inspiration piece is really important. So you are going to see spaceports pop up around the world. We're part of the Global Spaceport Alliance. And I feel like every meeting there's a new spaceport that's joined the alliance. Of course, not all of them will get to that point, but I think over the years, as technology changes and we integrate into general kind of aviation and airports, you'll start to see that there'll be more and more, and it'll become normal.
Yeah, it is. Like I said, it's kind of interesting that, up until this point, there just were all these monolithic, and you think about to try to get a rocket out to the Baikonur Cosmodrome in Kazakhstan, and you've got to go on a train and it's a pain. Or to think about the journey that James Webb is going to have to take to go to South America. It's going to have to go by boat. It's going to have to go through the Panama Canal. It's going to have to, it's just a ton of work. And I can imagine for a UK satellite provider, they've got a satellite that's in that range, 300, 500 kilograms. They manufacture it, they deliver it to Virgin, it flies on an upcoming rocket, they iterate. It's a much different way of just doing that work.
Yeah, exactly. And it's quite the Virgin way as well. So it's a red carpet service. It's that dedicated launch that, you book your slot, you're getting on it. You can plan that in, you can bring your customers along, you can show off, everything you're doing. It's just a completely different model. And it's putting that kind of Virgin magic fairy dust all on it as well. So there's something a bit prestigious about it. And And I think, for us, it's working with Virgin over the last kind of 6 years has been interesting because they're all about, how can we get local community excited about this? How can we get local businesses involved and the supply chain involved? And it's not just about them rocking up, doing a few launches every so often. It's about, how do we build an entire capability in the UK around this? So it is very different from what we've seen in the past.
So if people are wanting to watch, is there any way for people who live in the UK to come and check out the facility now? Are there any tours that you're giving, or is that still yet to come?
Well, yeah, not yet. Obviously, we're over here in the UK. We're in a lockdown number 3 at the minute. Of course,
yeah, no, like post-lockdown.
So we do have plans. Yeah, because it's a civilian airport. I think that's what's exciting. You'll be on your flight up to London and you'll look out your window and see Cosmic Girl about to launch to space.
Yes.
So, having that is just going to be hugely inspirational, we feel, and exciting. It's a massive site. So people will be able to come and see it, but we are definitely planning to have, visitor tours and working with some of the other companies that are already up there and kind of collaborating on amazing ways that we can show off space and aerospace and some of the great technology. So it's kind of one big happy family at the airport, and we're just slotting into that. So there's already stuff going on, but we're just going to kind of bring a little bit more to it. So we're building a new hangar at the minute, and alongside that will be some education outreach facilities as well, some visitor areas as well. So yeah, it's fully planned to make sure that everybody can come up and witness, a launch on their own doorstep.
Yeah, and that's the thing is that seeing a launch, just being part of that is pretty exciting. I've been out to Cape Canaveral a couple of times, and it's just great to just see. You sort of learn the history of space flight, and then you actually get to watch it happen, which is great. And again, when do you anticipate sort of the first use of the facility for a space flight?
Yeah, so our first launch is due early 2022. So we're just finalizing exactly when. It was meant to be October this year, but the pandemic's kind of shifted that. The only thing we're waiting for at the minute over here in the UK is a space flight regulations to pass through Parliament. So it's a piece of legislation that we're waiting for to allow space flight in the UK, because it's never happened before. So once we get that back, we apply for a spaceport license to just make sure everything we're doing is, as safe as possible. And we've thought of every potential outcome. And that's it. And then we're ready to go. The infrastructure, we don't need much on site because we really just need the runway more than anything, and that's there. So we're doing a few enhancements to the airport that's already underway now. So we should be ready to go by the end of this year. I'm looking forward to a launch, and it's going to be quite a big deal. We will likely be now the first place in the UK to launch. So it's a full-on, Virgin style festival around it, and it's going to be a big tribute to the UK space industry and all the good stuff that has been happening over here for decades. And this is it's going to be a big show off of what's good in space in the UK. So yeah,
great. Well, if people want to follow what you're doing, where should they go?
Oh, we're all over social media. So our website's probably the most out of date thing. So maybe not head there. Twitter, we're at Space Cornwall. I finally bit the bullet and got on Twitter a few weeks ago, and that's just gone mad for me. So I'm at Mel's Good Space.
Pace yourself.
And LinkedIn, all the teams all over LinkedIn. You can find us there, and Instagram. We're on everything basically. So
Wonderful.
Just look up either Space Cornwall or Spaceport Cornwall, and you'll find us.
That sounds great. Well, congratulations. I look forward to
Fraser.
The first launch. We'll of course be covering it on Universe Today once you actually fly. But yeah, really exciting, and good luck with the future of space flight from the UK. I can't wait.
Yeah. Say hi to Comox for me. I miss it.
All right. Thank you.
Thanks, Fraser. Cheers. Bye.